all, but we're going to do a little bit of review before, and we're just adding and subtracting, and so things have to be, have to be in a certain way. So from way back, what is that? Negative 5x. Okay, and so, I think the way to think about this is, right, we have 2x's here, we take 7x's away, and so we have negative 5x's. Right, it's not x's, it's just x. What about what's that? Same, because why? They're not like terms. Okay, so it's not that they can't be together, you just can't combine them into one term. So the answer would just be 4x plus 7. Okay, and then what about that? For the same reason, right? They're not like terms. Okay, so you want to look at terms with radicals in kind of the same way as you look at terms with variables. Okay, so things that you should notice. Oh, and let's do one more just to kind of make another point. What's that? No. 10x squared, okay? And the point of that is that the exponents don't change. Only the coefficient, or the number out front, changes. Is that okay? Okay, so again, this is the way you want to look at terms with radicals. Some of them you can combine, some of them you cannot combine. But for the most part, if you can combine them, you're only messing with the number out front. Okay, so there's a couple things to talk about. So radical terms can only be added or subtracted if the indexes are the same and the radicands are the same. What are the radicands again? Yeah, the inside, right? The inside numbers have to be the same. Okay, so for our purposes, if you see two indexes being different, you're pretty much saying I can't combine them. There are probably problems that we could come up with where you could do some serious simplification and then the indexes would become the same, but that's not anything that we're going to worry about. So pretty much if you see that the indexes are different, you just say I can't combine these at all. And so then you're really worried about the radicands at that point. All right, so the first problems that you're going to worry about, the radicands are already the same. Okay, so the indexes are both 2, the radicands are both the same. So just like terms, all we're messing with is the coefficients or the numbers out front. So really all you're doing here is saying 4 minus 7, which is, okay, so then this is going to be negative 3 radical 2, because that part doesn't change. Is that okay? All right, so just for the fun of it, we'll do another one. Okay, the indexes are both 4, so that's good. The radicands are both x, so that's also helpful. What's that? So 21 fourth root of x, yeah. So, yeah. Okay. So those are pretty simple. I mean, there's not much to them. Okay. So, but there is a chance that your indexes are the same and the radicands are different, but yet you can still add or subtract these together. Okay. So, if you like the steps and you like to write it out, if the radicands are different, you should check to see if, that's supposed to be an if, you can simplify so that they are the same. I don't know. Okay, so maybe this works, maybe it doesn't. And maybe that's clear, or maybe it's not, but it'll make more sense when we do an example problem. Okay, so basically, if the radicands aren't the same, the very first thing you should do is see if you can simplify one or both of the terms. And if you can, and then they both have radicands that are the same after that, then you can combine them. Okay? So we'll do a couple examples of that. Okay, so the way it is right now, there's nothing we can do. The indexes are the same, so that's nice, but the radicands are not. You're not going to go anywhere with the square root of 2. That's as simplified as you can, but you need to check the square root of 8 and see if we can simplify that. Okay, and maybe you can do it quickly, maybe you can't, but you can still always make the factor tree. So let's check it out. You take 8, break it down to 2 and 4, and 2 and 2. And we're looking for groups of how big? 2, okay, and so then we have 2 2's. What happens to those 2 2's? They're a group, and so they come out front. So this term stays the same, 6 radical 2. Plus, what happens with all this?
Multiply.
Okay, so right, so it's 5 times the group of 2 that you brought out. Square root of. Okay, so really this is 6 radical 2 plus 10 radical 2. Okay, and so now, in fact, you can't get those together. Is that okay? We'll do one more of those. Okay, important that the indexes are the same. You guys aren't going to have to worry about it if they're different. And then, maybe at first glance they have nothing to do with each other, but you always have to check, and hopefully I just made that up right. I hope it did. Right, that's silly. Right. We'll find out, though. Okay? So we're looking for groups of what size? 3, okay? So let's take them over here and find out. So 54 breaks down into what? 9 and 6, okay. 9 breaks down into 3 and 3. What about 6? 3 and 2. Okay, and so we're looking for groups of 3, so here's a group of 3. And so just like before, those come outside, right? So right down here, so that's 5 times 3 cube root of 2. Is that okay? Now we better check 16 also. So what's 16 break down into? 4 and 4. 2, 2, 2, 2. We're still looking for groups of size 3. Okay, and so we have one right there. So we have minus 6 times the 2 that we brought out, cube root of 2. And so in fact we can get these down, right, because we have the cube root of 2 in each term. So what's this first term become? 15 cube root of 2 minus 12 cube root of 2, which is 3 cube root of 2. Is that okay? All right. 1 to 16.